Hi guys, Mrs. A here. Today we're solving logarithmic equations. We solve these kind of similar to how we solve exponential equations, but we want to sort of work backwards in a sense. But we have to make use of the laws of logarithms here, and the most important thing to remember is that I'm just going to write this, if we have the log of something, let's call it m, to the base b, equal to the log of something else, let's call it n, to that same base, then we can say that the somethings, the m and the n, are in fact equal. So we're going to make use of this fact when we're solving logarithmic equations, and we're going to manipulate them to give us log of something equals log of something else. And then we can sort of cancel out these logs in a sense and just make what's inside of the logarithms equal to each other. Now there is the restriction. Remember that the base and what's inside of the logarithm must be greater than 0 to satisfy the domain of the logarithmic function, but otherwise we can make use of this fact. So let's go back to the logarithmic equation that we have here. I want to get log of something on this side equals log of something, which we already have on the right hand side. So I need to combine these two together. Well, we're adding logarithms with the same base, so we can use the product law of logarithms here. And so this portion is going to become the log of 2x plus 1 times x minus 1, and I still have log 9 on the other side. So now take a look at what we have. Log of something equals log of something with a base of 10 here. So we can essentially cross off the logs and just deal with what's on the inside of this logarithms here. So this is going to become 2x plus 1 times x minus 1 equals 9. This is just a quadratic equation that we know very well how to solve. So let's simplify and solve this quadratic equation. So when we expand here, we get 2x squared minus 2x plus x minus 1 equals 9. Now I'm just going to bring everything over to one side, and we're left with 2x squared minus x, and when I bring the 9 over, minus 10 equals 0. So there's a quadratic equation. We can solve this by first trying to factor. If you can't factor, then you know that you can use the quadratic formula, but I'm going to try to factor this first. So remember, this is a complex trinomial, so we have a product of negative 20 and a sum of negative 1 here. So our two numbers are going to be negative 5 and positive 4. So I have to factor this by decomposition. Remember how to do that. You can look at one of my other videos if you forget how to factor by decomposition. Here we go. Okay. And now if we factor the first two terms, we get x and 2x minus 5. And then the second two terms, we get 2 and 2x minus 5. Okay, so we'll take out this common factor that we have to get 2x minus 5 times x plus 2 equals 0. So our solutions here are x equals positive 5 over 2 and x equals negative 2. But remember this restriction that we talked about here, where everything inside of the logarithm must be greater than 0. So we want to always check the solutions we get in solving a logarithmic equation to make sure that in the original equation everything inside of the logarithm remains positive. So we're going to take this 5 over 2, and if I plug it in here, 2 times 5 over 2 plus 1 is positive, so that's good. And here, 5 over 2 minus 1 is also positive. So we know that this solution is in fact a solution. Now, let's check the -2. So if I plug a -2 here, then 2 times -2 plus 1 is a negative number. So automatically, without even checking on this side, we have the logarithm of a negative number here if we use that x equals -2. So we're going to eliminate this solution and call this an inadmissible solution or an extraneous solution, because that can obviously not be a solution for this logarithmic equation if it makes the logarithm of a negative number. So the only solution that we have here for this logarithmic equation is x equals 5/2. Thanks for watching. Mrs. A Loves Math.